Okay, so objective 2, now we're going to talk about the mean. So of course, when we look at the mean, we know that the mean is just the average of our values. Here is the formula to find the average. You sum up all the values and then you divide by the number of values. Now this X with a bar across the top, that is pronounced X bar. And what it stands for is it stands for the sample mean. When we get into chapters 6, 7, 8, potentially 9, we will use X bar a lot. Okay. Now down here, I just wanted to show you some extra notation. So this formula up here in written terms is the same as this formula right here. This Greek symbol is pronounced sigma. So if you want to join a fraternity or a sorority, that might be one of your symbols. But sigma just means sum. So that's exactly this word sum, that's sigma. So again, we're summing up all our x's and we're dividing by n, which is the number of data values. Okay, cool. So let's do a problem involving the mean. All right, so it says, how high is the score? How many runs does the Lawrence High School baseball team usually score? The dot plot displays the data on the number of runs scored by the team in all 21 games played during a recent season. The dot plot suggests that the game in which the team scored 12 runs is a possible outlier. Calculate the mean with and without this outlier. What do you notice? Okay, so again, it has the dot plot. So I'm going to go ahead and use this dot plot to type in my data into the stats applet. So I took a picture. So I'm going to go to the stats applets again. Again, we're doing one quantitative variable. And again, when you're reading a dot plot, each dot is a data value. So there's 1 0, there's 3 1s, there's 4 2s, there's 3 3s, 2 4s, 2 5s, 2 6s, a 7, an 8, a 10, and I'm going to include 12 in this one. I'm going to begin my analysis. Let's go down to the summary statistics. There are 21 numbers, and I do have a mean of 4.13. So again, this is what I'm looking for. I'm going to write that down on my piece of paper, but the mean I got first with the 21 or with the 12 included was 4.143. Now let's see what happens when we take that 12 away. I wonder if you can predict what you think might happen, right? Do you think it's going to stay the same? Do you think that means going to change? Think about that before you, before I do it. Okay. So for some reason that's not going away. So hopefully it does soon. Let me see if I can. Nope. Okay. It's here to stay. All right. So let's see what happens when I come up here and let's. I don't want to reset. I'm just going to take away the 12. So watch what I do. I just erase the 12 and I'm going to press begin analysis. Now it's going to say, are you sure the entries will remain but unsaved? Yes, I'm okay. And now I click begin analysis again. Okay, and now notice my dot plot is one number less, no 12, and now I'm at 20. And now look at my mean. My mean is 3.75, so I'll write that down, 3.75. Okay, so let's answer the question. Okay, so the mean with 12 was 4.143 runs. And the mean without 12 was 3.75 runs. So what happened to the mean? What do you notice? So I'm going to say something like when the possible outlier oh sorry, that's bad spelling, outlier, get ahead of myself. When the possible outlier of 12 was removed, the mean decreased from 4.143 to 3.75 runs. So thinking of it in a reverse fashion, when 12 was included, the mean was a little bit higher. But once you took that high outlier away, that 12, your mean shrunk. It went away from the 12. Okay. Hopefully, you didn't think the mean was going to stay the same. All right. All right. So, what does this mean? Well, this is a very important slide right here. So, pay close attention. Right. This idea of resistant is very, very, very important. A measurement is resistant if it is not influenced by unusually large or small values. Of course, we know those values to be outliers. So notice in the last problem, the mean changed when we had the large value included and removed. So therefore, your mean is not resistant. Outliers affect the mean. This is why I said when I do my grades, sometimes I don't use the mean because I don't want those high and low values to affect it. The median is resistant by removing one value on the end of the data set, either high or low. It should not affect the middle value too much. Very, 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 very important idea here about resistance. Okay.